good understanding, understanding of the fundamentals in the chosen area uh, is done in that course. So if any high school students are interested, maybe you can also take part in that. And we have one more very uh, popular program, or the very uh, popular program is the research education in advancement, research education advancement program called REAP. So there are two wings here. One is physics and another is biology or life sciences. So it is for undergraduate. And on the second Sunday, we have a program called Science Club, where actually uh, a demonstration is science phenomena is explained through demonstration. Some choose topic will be announced, and there will be a demonstration or discussions about the topic. That will happen in the what we call Science Club. On the third Sunday, we have a science movie projected on the screen. So you can enjoy some of the documentaries on science. So it may include life sciences, physical sciences, astronomy, or any branch of science. So that happens on every third Sunday. On fourth Sunday, there will be some interesting lectures. Right? So at present, actually, there are series of talks that happens on the contribution of technology, right, of space technology in understanding the Earth or Earth sciences, or uh, the sciences which are related to us in every day. So the title of the series is Benefit of Space Science, right? So this happens on every fourth Sunday. So there are various programs that may interest you. For all the information about when actually it happens, where it happens, right? All those things you can on our website. So the speaker of today's talk is so, and, hand it over the mic to Sharanya now.
Sir, thank you all for your patience. Without delaying the program much, I invite our director and the speaker of today to please occupy the seats on the dais.
Kindly bear with us a few moments. Professor Sebastian Peter is man. I would request you to be patient for a few moments.
Thank you so much. A very good evening to everyone present here. A warm welcome to the third talk of this year's Dasra lecture series at JNP Bangalore. Over the last few days, in the past week, we had two lectures of this series focusing on nanotechnology, nanoscience, and the origin of life. Now today's topic is about carbon and climate change. Carbon is the same element that forms the basis of life and also plays a central role in shaping our planet's climate. And understanding how carbon moves through the Earth systems is very important to face the challenges and explore the possibilities for a sustainable future. And today's speaker is here to talk to you about that. Now I invite our director, Dr. Guru Prasad, to formally welcome you all and also to introduce the speaker.
Respected Professor Sebastian C. Peter and audience who have gathered here in the civil hall despite the fury of rain god and weather god as such. And those of you who have joined through online to this lecture, ladies and gentlemen, and my colleagues at JNP. Good afternoon to all of you, and welcome to the third lecture in this year's Dasra lecture series. And this is the third talk. My special welcome to Professor Sebastian Peter. It's a really a miracle that we have found him and we have persuaded him to come. Okay, let me tell you how busy he is. He was telling me, see, after this lecture, he has to go back in Bangalore traffic. Then he has to catch a flight to Tokyo tonight. He is so busy because he is not only an academic, there are so many fields in which he is very actively involved. Okay, anyway, all of we expect a lot from this lecture because carbon and climate change, how to circumvent this or how to manage this. At the same time, how to, in addition to managing it, whatever carbon that is being released, let us say, let us prevent it and make certain things which are useful for us. That is what he is going to talk. So it is an added thing, okay, value added income while managing the carbon which is released into the atmosphere, which is being released even though it is being reduced. Now, before I introduce let me thank people who have made this lecture possible, as well as this year's Dasara lectures. We had a committee consisting of Professor Ajit Parmeshwaran of ICTS, Professor Nagasuma Chandra of Indian Institute of Science, and Professor Ranjini Vishnatha of JNCAS. All of them helped us a lot in finding the speakers, okay, and at the same time, let me profusely thank, place it on record, the help rendered by Mr. A.N. Jayachandra of JNCASR, who is my very close friend. He was the person who introduced me to Professor Sebastian Peter. And we are very fortunate today he has come to deliver the talks. Without wasting much time, let me introduce Professor Sebastian Peter to you. Professor Sebastian C. Peter is professor at New Chemistry Unit in School of Advanced Materials at Jawaharlal Nehru Center for Advanced Scientific Research near Jaipur. This was founded by Professor C.N.R. Rao in November. And of course, this is not the only domain in which he is very active. Besides being professor there in the New Chemistry Unit and School of Advanced Materials, he is the co-founder and director of Pre Applied Sciences Private Limited. I will come to that a little later. And he is the convener for National Center National Center for Carbon Capture and Utilization. This apart is the national coordinator of Indo-Japan DST-KE synchrotron facilities. You can see how busy he is. Wonderful. And the fact that he has come here shows that his love for this institution. Thank you, sir, once again for creating this academic place. Professor Sebastian C. Peter received had a very illustrious academic career. He got his MSc from St. Thomas College, Mysore, the cultural department, and he ended from Cochin University of Science and Technology. Professor Sebastian Peter received his PhD in chemistry from the University of Münster, Germany, and he was a postdoctoral fellow at Max Planck Institute for Chemical Physics of Solids, Dresden, in Eastern Germany, and Northwestern University, United States. Dr. Peter joined as a faculty fellow at the New Chemistry Unit for Advanced Scientific Research, Bangalore, in 2010. Coming to his research interests, they include development of inorganic materials for various applications ranging from fuel cell, CO2 reduction, and condensed matter physics. All the three are very exciting domains. He has more than 210 peer-reviewed publications. Amazing. He was invited and attended around 100 national and international. Professor Peter is the recipient of Young Investigator Awards from American Society 2013, RSC 2017, and IOP 2016. He was awarded a Ramanujan Fellowship in 2010, MRSI Medal in 2016, Swarna Jayanti Fellowship in the category of Chemical Science in 2018, and CRSI Medal 2020, and many more. Professor Peter is a member of American Chemical Society, Royal Society of Chemistry, ASM International, Chemical Research Society of India, a Material Research Society of India, International Union of Crystallography, Indian National Young Academy of Science and Society for Material History in India. Professor Peter is the founder and director of the startup, you should remember this, Breathe Up Applied Sciences Private Limited, and entered into the final round of the NRG OSIA X prize of 20 million US dollars on waste CO2 utilization. This is very important. This team is the only team in the final round of the competition, earning $500,000 US as a milestone. Breathe Applied Sciences Private Limited has been selected as one of the best 100 startups by the government of Karnataka and in 2017 and through Elevate. Outside the country, Clean Equity, a firm in Monaco, okay? Heard the name Monte Carlo, okay? Selected CO2 reduction strategy technology as the second best in the global level. Like this, I can go on and on and on and on. He has received so many accolades naturally from various countries, and he has visited more than 50 countries. He's a member of American, he's on the board of the Journal of American Chemical Society, Chemical Science, Chemical Sustain, Chem, and Journal of Solid State Chemistry. Now, he has been selected for the Rajiv Goel Prize in 2024. Finally, Dr. Peter is currently visiting professor at IIT Roorkee and adjunct professor at Shiv Nagara University. So, a person of this eminence has graced the occasion. A big round of applause to the all the youngsters here and the general public to inspire you. Definitely. I'm sure about it. And let me, at this juncture, before I go, let me thank all our technical staff as well as the others who have helped in this regard. Today we are streaming it for the first time using our own facilities. I know how much of work has gone in the past a week or so in making this an indigenous effort on the part of the JNP. Thanks to them. And today, more than 100 people are watching online as far as this lecture is concerned. And now I welcome once again Dr. Peter. And now I request Sharanya to bring the memento here and as well as sadly to honor Professor Peter. I'm honored to hand you over a model of our LVM3 rocket, which I announced earlier also, affectionately referred as Bob. Thank you.
I would also like to offer my dedicated support.
Good afternoon. Thank you. Sir, thank you, sir. I'm overwhelmed with such a detailed description about myself in my abilities. Well, I got here when I started, I was supposed to reach at 3:40, got into the traffic and then, yes, sorry for that, apologies. But I will try to know after that. So, well,
You can see that my t-shirt is also made. Okay, so when I gave it to college, I did not have any mentor when I went to the board and I got a t-shirt, but I was looking at the t-shirt today morning, I found it and then I was, so I got an IDT app to my call. Well, Ted is here, I'm here, and you got enough of what is the background.
As one of the leading drivers in climate change, CO2 is a problem that's only getting worse. But what if we didn't have to choose between our economy and our environment? What if we could turn our carbon liability into an asset? The truth is, CO2 can be recycled into valuable products at a scale that could transform our global economy, but it won't happen on its own. The NRG COSIA Carbon X Prize is a $20 million competition to convert carbon dioxide into valuable products.
CarbonCare's technology takes CO2 and converts it into stronger and greener concrete. Our process makes a very nutritious protein.
From carbon emissions to bioplastic.
Carbon negative biofuel.
Plastics and other sorts of materials.
Carbon nanofibers.
Feeds for fish.
We take carbon dioxide and water and we turn that into alcohol. You can drink it to make yourself feel better.
My motivation for competing in the Carbon X Prize is my son. What am I going to leave for him in 50 years, 100 years, and what about his kids and their kids?
There's a sense out there that climate change can't be fixed. That's something that we just adamantly disagree with. 38 teams from around the world accepted the challenge. After 2 years of development and testing, judges have narrowed it down to these 10 finalists. Teams must scale up and demonstrate their technologies using emissions from real power plants. The finals will take place at 2 new test centers, one in Calgary, Alberta, and one in Gillette, Wyoming. The stakes have never been higher. Together, these solutions will help transform our economy and redefine our climate future. Imagine a world where everything around you is made from carbon emissions. From the products you use every day, to the clothes you wear, to the roads you drive on, to the buildings you live in. Welcome to the circular carbon economy.
Okay. Yeah. Okay, so I
I just want to show that video because I started journey from there. So then, this is in 2015. I was a medical scientist. I'm a chemist, basically I'm a chemist. I have 2 degrees, one chemistry and one chemical engineering, master of science and master of technology. Both we used and then started the journey back in 2015. It took us 6 years to reach a level that we are demonstrating a technology. Okay, how the journey? That's what I'm going to talk about. But before that, I will show you a few figures. You know this one, photosynthesis, right? How many of you know chemistry and little bit background? Nice. Okay. Basic chemistry, I'm not going to the detail. You know photosynthesis. You already studied that. You got a beautiful in the nature created by somebody, and then we are enjoying that. And you see that one carbon dioxide extensively used here with the water and everything. And this is the image taken from the Google. This is the Bangalore city, 1973. You can see that. 1992, 1999, 2002, and now 5 years back, 2020. Whatever all the green we had in the past has gone. The first time I visited Bangalore, 1998, as a part of a study tour from my college, and I was a bachelor. It was really nice. In the morning, without any jacket, you cannot go outside. Even in the summertime, I used to hear from my senior colleagues. It is kind of some pleasant place. But now the situation changed completely. We don't have most of the trees that were cut down because of the urbanization. So what happened once we crossed 40 degrees? Okay. And if I take it further, do that. Yes. So if you take it further, that beautiful photosynthesis added this one, and emitting excess of CO2. Okay. Earlier that was green, then you are adding a little bit of extra CO2 that we call as anthropogenic CO2 that is created by human over a period of time because of industrial revolution, urbanization, all happening. Okay. And if it is taken further, if you look at that, this is from 2 years before report, carbon cycle, around 5.1 gigaton of CO2 is emitting after this is considered by the forest or deforestation or whatever an additional, the ocean sequestration, everything, 5.1 gigaton of CO2 emitting. Now it's nearly 7 gigaton. Okay, and if you look at this image, whatever you are using daily life, whether it's your shoe or umbrella or all the toys, you can see anything that can be produced from oil. And you can see that when all these are in the energy sources, whatever in the automobile, you can use it in oil. Okay? So anything that you have in hand that is coming from oil discoveries. Nice. And if you take it further, this extend that one. Okay. You know what is this one logo? WhatsApp, right? What is that? Okay. What is this one?
Instagram.
Nice. And if you go further, PlayStation, right? I think most of you use this one, right? How many of you have mobile? Don't have mobile? You don't have mobile? At least you must use the mobile sometime. Most of you, when you get up and what you do, first you put alarm, no? Right? So with the alarm, I mean, you just switch off the alarm. And then what you look at that one, what I look at, I mean, first one I look at it. Okay. First one I check WhatsApp. Before email, we check WhatsApp. Okay. And when you get something interesting message, what do you do? Reply it. Okay, somebody said, hey, hello, how are you? Did you do something? Can I get some information? You just reply to that one. Right? You continue that journey. Depends on the number of messages, your time also will be much more. Then you just move to Instagram or Facebook or X. Okay? Okay, now some things are really good. I do that. But when you open the Facebook, what happens? You say some reels. Okay? When you see them in reel, you might have seen reel. Huh? Reels are really good. I mean, and then that reel drag you to another reel, and it will continue. At the end of the day, what you do depends on the extent of utilization. You have to charge the mobile. Right? So if you are continuously using, probably after 2, 3, 4 hours, you have to recharge. Maybe 2 times in a day. Depends on that, or 3 times in a day. Somebody is very busy in a mobile all the time. Okay. Then, where is this electricity coming from? Electricity. Somebody, I mean, take the coal, burn it, that electricity passing all the way to city, you are getting. When that, the coal is burning, what is happening? The carbon is burning in the form of CO2. Okay. So what happened? One high equivalent to one CO2. Right now? Right? Your each high is equal to CO2. Unknowingly, you are participating in the global warming. Am I right? Nobody can escape from this one. Should I stop? Okay, don't use it. No, you want to use it. Otherwise, the whole communication will go. You shouldn't. We are living in a world, digital world, we cannot escape from that one. And we are living in the world of OTT. Right? Number of movies released in different languages. I don't think we can cover all the movies. Watching. You're using computer, you're using all the electronic. Maybe in your house, you have 3, 4 vehicles are there. You're using each one contributing. Somebody say, no, I am using bicycle. I'm not. Okay. So each one contributing in such a way, this one. Okay. It's working now. We started the journey here. Okay. And you can see that there is one aspect. Okay, I'm talking about the items you are using that is coming from oil. Now, energy. You can see that petroleum, natural gas, coal, renewable, and nuclear. You can see that coal is a kind of a stabilized because there are a lot of policies on not used on coal extensively all over the world. And now, this is in British thermal unit, quarterly and British thermal units, and you can see that the demand is getting higher. This graph will step further this way, not this way. It will go this way. When you do this one, it will contribute. Okay? You burn carbon, and you get this much energy, and you get one CO2. If you are using methane, you are using LPG in your home, right? And one LPG cylinder probably you are using 2 months. Okay. If it's only one time, probably 4 months. If it's 3 times, maybe 2 months, like that. Or if you are using something like the petrol or diesel, you can see that with 8 molecules of CO2. You see? Right? If you drive a car, 10,000 kilometers, 8,000 kilograms of CO2 is produced. how many cars in Bangalore? I really are struggling to reach here. Okay, so just imagine if you take all cars in Bangalore and then calculate the CO2. Not only that, the car in every traffic, they are not switching off the engine. It is not. And each traffic element producing a large amount of CO2. It is a chemical. Alright. Then, what are the sources? If you look at the stationary sources like the fuel cell based electric power plant, independent power producers, manufacturing plant, cement, limestone, hydrogen, ammonia, soda, chemical oxidation, commercial and residential building, private of gas, military and government facilities, like the mobile sources like cars, ports, utilities, vehicles, trucks, and buses, crafts, etc. etc. And natural sources like human, animal, plant, animal decay, land emission, volcano, earthquake, etc. The last column taken care of by the nature. Last column taken care of by nature by the photosynthesis process. The first two columns, the other two columns, man-made. Called as anthropogenic. Without having any thought process, we did the development, but ended up in dumping CO2. To take it further, this is a cartoonic video, kind of it. You can see that CO2 level, more than a century, started something around 250, increasing 400, and you can see that season January to December. You can see that it's not exactly perfect symmetry. Depends on the monsoon or summer, winter, the two things. But when you take an average value, it kind of close to 2 degrees C in overall. 1.5 or less than 1.5 is happening overall. For example, if you go to Delhi, CO2 level sometimes it reaches 750 ppm. That's very high also. And last year, most of the offices schools were closed and they were asked to work from home. Okay, having to have in your school do the online classes from home. But the reality is actually if you are sitting in home all the time, even also you are struggling. It's not good. You should go to school and enjoy it. It's happening, I mean, in over a period of time, it's increasing day by day. And if you look at that, in the next one, I have taken this one, it's not a Jan, it's something not updated. Today, oh, it's not updated. Today morning I checked that one is 426 ppm. If you go to this website, co2earth.com, you can Google it. Every day, I mean, you can get the changes in second decimal. Okay? And you can calculate, I mean, 1 year change to 1.3%. You can do the mathematics. Today, I mean, 2025. Next year, I mean, 1.5%, I mean, that will be additional 5 ppm. And 5 years, I mean, 25 ppm. And then 10 years, I mean, 50 ppm. And then 25 years, I mean, 10 plus 5 plus 25, I mean, so that will reach, I mean, close to 600 ppm. 600 ppm, if you are continuing this way. So, the situation is such a way when we are going in this manner. And this is from International Panel on Climate Change. The report, you can Google it and read it, and you can see that this shaded area is going to be underwater. You know Dwaraka? Dwaraka? Dwaraka city? It is there underwater. It is there. If you go to the Gujarat seashore, it is underwater. Over a period of time, when this global change is coming, you know, it is gone underwater. Or the famous, I mean, you know, the Ramayana back then, there was a bridge between, I mean, you know, Sri Lanka and India. If you just Google it, I mean, there is a small, you can see that. Okay, over a period of time, that, you know, this changes will happen. And if you are not taking an action, this area is going to be underwater. You do not have city like Mumbai, you do not have city like Chennai, and safely we are in safe position. We cannot trade anywhere. And most of the people staying near to the seashore, they will suffer. They have to migrate to the different place. That migration will affect your sustainability. Okay? Not only that, one. This will also affect the marine life. How? Water react to the CO2 and it will form carbonic acid. And the carbonic acid will change the pH of water. The pH will become acidic in nature. When it is acidic in nature, fish's life will be in danger. And you are going to eat that fish and that will affect you as well. Okay? So whatever you are eating, probably the fish is near to the ocean seashore, it is actually a kind of damage. It is not safe. Our health system is also affecting. So you can see that this is already mentioned that one automobile, this is the steel industry. You know that this is steel industry. This one, cement industry. This is fuel panel. All are actually contributing. Already I mentioned that one. But yeah, I'll take a few examples. You know this guy? Nemo, right? You might have watched this movie Finding Nemo. Tony also. Next part. Okay. During the PhD, what? 10 times probably. Okay. So, see that one, Nemo died. He felt unconscious, no, at that time. During that, hunting of, this one, he felt unconscious. You take something more? Okay, seas having fishes are dying. Many are massive dying. And this is the infected. Okay, and then you are getting a fish and from the market probably do not become. Okay, if I go here further, see this is one I'm talking about. There are a lot of numbers here, and the trying to inject to the soil and then over in the ocean, take care about that one. But when I take this one, so for example, if you have 1% of CO2 per year, it can end up in drowsiness. Do one thing, take your bicycle, go to one side of the look and go. Just do it. Yeah, but if you get a chance of whatever short distance you try to do, you feel that take it. Exposed to that pollution. Okay, if you have 3%, that reduced clearing, mild narcosis, heart-related problem, 5%, dizziness, confusion, headache, 8%, shortness of breath also, breath loss is coming into the picture. So, in the opinion, depends on what are the percentage of the CO2 that will affect your health system. Often we talk about global warming. That's not the case only. It is also affecting your health. For the technology development, for the urbanization, and we proudly say that we are getting a lot of money from technology, but at the end of your life, you are spending all the money into the hospital. Okay, you get a lot, but at the end of your life, you are going to spend a lot of money for. Okay. It's a slow killing poison. It's not like a COVID. COVID was fast. It is much worse than COVID. Keep in mind. So we feel that we are safe, but after 20, 40, 60, 50, 60, you will realize that one it is going to really bad. Okay, well, you know this one, right? Who's that? Earlier, ex-President of the United States. He made a statement, development in India and China acts the carbon dioxide emission. That's what he mentioned. Okay, many people criticize. Okay, because we are responsible for global warming. But we took it as a pride because development is happening in India and China, that's the reason only the CO2 17 much more. So he took it, he statement was absolutely correct. And if you go to the first, next slide, you see that per capita CO2 emissions, the data says that the development happened, started in China, end of 20th century, it slowly started. You can see that here, these numbers here, India and China leading in terms of and we have the GDP higher than the other countries. If you have more GDP, as simple as if you have more GDP, more CO2. You are very proud to say that GDP is stable, CO2 is also stable. Because all the revolutionary changes on technology. If you look at this one, Japan, US, and Germany and UK, they're going down or kind of stable. How did it happen? There was the news. There was a shortage of CO2 in Europe. Why so, right? There was a shortage of CO2 in Europe. What is the reason?
People stayed in their houses.
I give the answer after 3 questions. Anybody can guess this why the CO2 was less? And so what is CO2? Think about it, okay? Just think about it. Okay, so to tackle all these things, yes. COVID, what is the connection with the COVID? Yes. Okay. For what purpose they need carbon dioxide? They are not coming outside. Your answer is correct. Are you in the carbon dioxide? You are sitting inside the room. No. Have started actually during the COVID. So, this is the sustainable development goals, and you can see that you all know that 17 sustainable SDG, and basically we are here 13, but it connected with the many parameters. I can talk a lot, about this, connected with all of this one. So, for example, water, I was talking about, it can be also connected with, for example, good wealth and well-being state. Anyway, I'm not going to discuss much on that one. And as a part of that one, they thought of doing what to do. First, capture all CO2. Not about anything. Okay? You are anything, why don't we capture? But the problem, he is like the ghost, you just put him outside. But that day will not come the same fashion we are keeping him outside. Not easy. Okay, so it's not possible. How much you will just capture? There is a limit for that. The amount of CO2 that you are putting outside, you cannot capture the same fashion. Okay? Either you utilize and then get it back to original one. Okay, next slide. You know this one?
Yeah,
Kingfisher. What is this one? Huh? Why they are connected? Kingfisher and sugar? Sugar gets fermented and produce alcohol, ethanol. Right? That's the process is happening. Okay. Next one. You are getting alcohol. Okay. When you do a fermentation, a lot of CO2 is also emitting. Keep in mind. Okay. Next slide. The next one. Yeah. It's not lighting. Air pollution. Yeah. So somebody's cleaning. What do you use to clean? What is that in that one? Acetone. Nice. Okay. Ethanol, acetone. Next one. Yeah. Sanitizer. What is that? Which alcohol? No. Huh? That is ethanol. Okay. It's an expanded version of ethanol. No? Propanol, isopropanol. There are two different propanol and isopropanol. Okay, next one, this one. Polyethylene. Huh? Polyethylene. From ethylene. Ethylene polymerized and then getting the polyethylene, whatever the plastic cover we are getting, that one. Next one. This one. Fruits. There are two different types of fruits. One is semi-frequent fruits and then there is a non-one. What's the difference? When you just go to the food shop or you buy a apple, for example, actually, they can keep it longer period. Right? The same apple, you go to the field and pluck it and then keep it in your home. The ripening will happen faster. Check it, okay? Like I had this problem. Once it happened, the whatever I bought it from somewhere, it's not actually ripening, it's not damaging, it is 2 months, 3 months, it was sitting there without any problem. Exactly. Okay, the slow, what you call, it's about whatever the before ripening, if you pluck it, ethylene is coming outside from this category, it will be slow process, and doing it a slower process, and you can keep it a longer period. Okay, next one. This one. Concrete. Concrete, right? Made up of cement. Made up of? Next one. That guy. Petrol, diesel, we can consider both. Perfume. What is that perfume? Yeah? Ester is not alcohol. Cover your person around that area. Isobutanol. So isobutanol, that is giving the fragrance. Okay, next one. What is this one? Urea. Right? Okay, next one. No, picture is not clear. Our sheets under the field can get it. You can see polycarbonates basically. It depends on this one polycarbonate or other or starting materials. So this is polycarbonate. Next one. What is this? Vinegar, acetic acid inside. Right? Next one. Can you cook CO2 at home? Maybe. Literally, can you cook CO2 and eat it?
Yes.
Exactly. That's what. Next one. So all these items containing what? Best one. What is it? Honey, food, what is the? Proteins. Right? Okay. Next one. You might see when you go there and you can, get just fruits and vegetables in the packet, right? Why they kept it in packet? How? They just add more CO2 along with the nitrogen and the oxygen to avoid the oxidation process. Okay, damage. Next one. Somebody told that. Okay, next one. This is what you call I have taken from sources of greenhouse gas emission from US food production. If you eat this much amount of percentage of CO2, emissions happen. Can get to this information. We are in the digital world, left and right, you read so many information. You can get it. Next one, please. Okay, alright. I have hundreds of examples. What I'm saying actually, you found so many compounds. All these compounds you can make it from CO2. CO2. We made it. Most of them. Okay, in our lab we made it. Most of them. My title is also, what is that? CO2. Because all this, I mean, whatever the daily life you are seeing, basically you can produce from CO2. From waste CO2 if you are producing, without losing that waste, I mean, efficiently convert into useful items for your daily life. Okay? I just ran through that one to make, I mean, give the feeling that one. Anything you can think about that you can make it from. Okay, so, well, I just bring this one, carbon credit. I'm not sure how many of you heard about this one. We just took it one more. This started in Kyoto Protocol 1997, and then after, I mean, 18 years, I mean, they started in the COP 2015. That is actually, I mean, it must be, you remember that, you know, the company made 2 degree, below 2 degree raise, or 1.5, it should be below that one. If it's above, you might have seen so many movies, you know, for example, all this Himalayan ices also melt down, and then, like that, if the graph shows the seashore, everything will be water. Okay, then, what is carbon credit? If you look at that one, 1 ton of carbon dioxide saved is equal to 1 carbon credit. Okay, tomorrow onwards, you don't text anything, WhatsApp, and count it. Don't cook anything, count it. And don't use your motor vehicle, count it. You walk to your school or bicycle, and then you save it. And at the end of the year, you calculate how much CO2 you saved, and you are eligible for 1 carbon credit. You will see, my parents, many things did not allow me. Seriously. Even they did not, never, I am from Kerala, they never allow me to go outside of Kerala. I ran away. Sometimes you have to give good justifications to convince them. Okay, it is not fighting, okay. Don't do the fighting. Because they have their own knowledge, their own understanding. And you should give the feeling that yes, there is something potential nature. I am telling about myself. My mother never wanted me to go outside of the house. And she never wanted me more than +2. She wanted to have a salary of 5,000 rupees after +2. I never satisfied. Okay, so parents, yes, they will look at your safety, they will look at your progress, everything, they will look at that. You also understand whether they are correct or not, and then you just okay, if you go further, if you want to have 1 carbon credit, okay, plan 46 please. You need a space for it. You can do the calculations. In 22 kilograms of CO2 per year, one tree can calculate and then multiply by 46 and depends on the size of the trees. We are just putting an average size. Okay, there is a space for that one. Not easy. Or what to do? Next step. You can also use 1 ton of carbon dioxide saving by renewable energy. 1 carbon credit. What are the renewable energy? You can talk about solar, you can talk about wind, you can talk about hydro. Yes. Okay, but I am not an advocate of this renewable energy. I will give you the reason. I will take wind energy. Wind energy is renewable energy. This wind fans, right? Big fans. If you go to Chitradurga side, say for example, there are hundreds of windmills out there, right? And what is the problem? When this rotates, it kills birds. Okay? Night time, it kills some bats. 100,000s of bats. These bats are good for eating worms that damages agriculture. Right? And when you are killing your whatever the protection, by this way, your agriculture is damaged. So you are basically damaging your sustainability. Getting the point? Okay, you only think about renewable energy, only think about the particular commercial aspect or security aspect, but you have to think about social action as well. How you are socially protected, sustainably protected. Wind energy is one example. You could have installed solar panel also. You need how much space and the protection of solar panel. So massive amount of CO2 is actually emitting. Actually, it is not a renewable one. Next one. Or 1 ton of CO2 captured and carbon credit, 1 carbon credit. The last one, 1 ton of CO2 utilized, 1 carbon credit. Actually, I have some carbon credit because I convert many CO2 to useful chemicals. But still, it is in what we call a small tip of an iceberg. We are nowhere near to that one. We are talking about 2070 net zero. I don't know. I may not alive because by the time I will be 93 years old. Whoever introduced that one, all will not be there at that time. So how you are going to tackle that one? Next. Yeah, I already discussed this one. I wanted to tell that one. So this is exactly happening. This is a massive study done by United States and Europe and they found that this is going to damage all the sustainable life that human beings have. If you go to the next one, I'm just getting that the solar panel also carbon footprint. Yes. Okay, there are 3 terms you can think about it. Carbon neutral. Carbon emissions equal to carbon removal. That's carbon neutral. When you see read the newspapers or social media or any other platform, carbon neutral, carbon CO2, carbon emission, carbon removal. Net zero contributions to net zero emissions, we are talking about, and then carbon negative removal of carbon from the atmosphere. It's like just capture it and then take it away. Next one. So our government also put some pledge on that. We have around 1.91 metric ton of CO2 emissions in 2022, and this is a 5 pledges. If you read one by one, zero emissions by 2017. Okay? To enhance its capacity for non-fossil fuel energy to 500 gigawatt by 2030, only 5 years away from us. Increase the proportion of renewable energy in the energy mix by 250% by 2030. Reduce the emissions intensity of its economy by 45%. Reduce emissions by 1 million tons of CO2. Who got Nobel Prize in Chemistry this year? Who got Nobel Prize in Chemistry? I feel very sad about chemistry. Chemistry is actually very difficult in school days also, I know that one. First difficult part is maths, then followed by chemistry, right? Physics also there. Then everything is better. Chemistry is easy? Oh, thank you very much. Most of the people and most of the students wrote that chemistry is difficult after mathematics. Okay, this year 3 scientists got. One from Japan, Kitagawa. Suzuki Kitagawa. Second one is Robson from Australia. And the third one is Omar Yaki from the United States. He was a refugee of Palestine. And his mother never knew writing or reading. Okay. Father was a refugee. He went there. He is educated. And then he used to do the CO2 capture by using metal organic framework. I have written an article, after tomorrow will be these types of video about Nobel Prize. You can read it. It will come Monday. Okay, so this is connected with how to CO2. Just want to tell that this is present. Yeah. So many countries, the overall globally 2050, some countries like Sweden 2045, they can do it because it's a kind of a developed country and it's a kind of saturated, it's happening that way. But India kind of country developing, day by day, it's going by, like a different level of, the development is happening. And in different industry also. So for example, Reliance, they put us 2035, Beauty 2040, HP, I mean, 2045, something like that. The different industry also they have own, the zero emissions strategic plan. And if you look at me, I will retire by 2043. By the 2043, most of the people are retired. Most of the people by the time will retire, and you guys are young generation going to lead the world at that time. Keep in mind that we need a lot of brain, massive support to protect our nature, protect our country, and just try to understand what is the seriousness of this one. Next one. So there are a lot of plans, R&D plans. You can see that global reproduction plan, CO2 separation plan, CO2 capture plan, CO2 utilization plan, CO2 disposal plan, and environmental friendly like hydrogen catalyst and other later items. We discussed a bit about that one. If you go to further, artificial removal, you can enter. Carbon sequestration, take the carbon, pump it down, deep, or you can take a channel to the sea and ocean, you can pump it, especially European countries. A few months back, I did a survey, completed in UK side. We traveled from Edinburgh to London, visited all these places and related to CO2 sequestration. And I would say, at least 300 years we are behind them, to be honest. Okay, they have an advanced technology. They take them to CO2 deep ocean, North Sea, and then they identify the location. They can store it. This CO2 can store for 100, 200, 300 years, and after 300, 400 years, and then they can dig it out like that we are doing on the oil. Okay, it's a massive one. So this is one of the best method we can think about, but in our country, we are in the nascent stage. Or, if you take it in chemistry, we just published one paper in chemical science. This is called cyclic carbonate. Take CO2, you can see that the CO2, just fix it in the epoxide and make it as a carbonate. Or you open the ring and you get a polycarbonate. You just plastic and the dioxide. We made it. Okay? So we can make it, and further engineering and all everything we can do it. You go further, you can capture CO2. We have done one work. I'll show you if I have the time. I think I don't have that time. So we have taken, this peanut, right? Peanut shell. India is the second largest producer of the peanut in the world. And what do? If you open the peanut and then throw the shell outside, right? What we did, instead of throwing, we took it and then processed and made a compound. That and compound captures CO2 and record value. So we can scale it up in a ton capacity. Okay, this is also waste. But instead of throwing outside, when you take that one and modify with the knowledge of the chemistry you are having and captures it. Next. Well, there are a lot of activities around the 700 projects all over the world is happening. This is just for an awareness. And you can see that you can read gasification, coal-based, natural gas-based, cement, SMR, production of hydrogen, and etc. That is in the case of, what you call CO2 capture technology, CO2 utilization. I showed a concrete. You remember? I did not comment anything about that one. What is there in concrete? CO2 can be used for making concrete. Now, during my introduction part, I mentioned that when I was a part of the final round of Express, $20 million. The winner was who made the concrete from UC Berkeley, India. He's coming in December, by the way. Okay, so 2 ton, when that was when during the period of the COVID, we could not go there. We already got the space and everything. So you can make a CO2 concrete from CO2. All right, so there are a lot of technology here, and I'm not going into the detail. And there are a lot of activities in my R&D center. Again, I'm not going into the detail. This is our center of excellence. There's another center of excellence in IIT Bombay. They talk about carbon capture, utilization, and sequestration. I was talking about pumping CO2 under the ocean. They are expert in that one. I'm not expert in that one. Okay, don't count me. I'm expert in only CO2 capture and utilization. Next one. Okay, little bit chemistry. I'm not adding much. Little bit. CO2 molecule, COO. Class 10, 9, 8. Which class you studied? 7. Oh, you are super good. I did not study that. COT is a linear molecule. Anything linear is very stable. Right now? So this, and then you also know that we'll see double bond law. Right? When it is a single bond will be typically strong, stable. Because of that reason, CO2 is very, very stable, you cannot activate it. That's the reason its technology is not too much. As a chemistry point of view, I'm talking about it's extremely hard. If you go further, this is a paper 65 years before 1961. This paper, if you talk about, assuming that I'm going to bend this CO2 molecule, someone just bend it. Okay? And what happens? The energy, total energy formation is coming down this way, or to make it a bend this way. Okay? What happened actually? This is angstrom. You know angstrom, right? What is angstrom? What is that? Can you see that one? What you can see minimum? That in the scale bar you can see that one digit, right? And out of that one 10 to the power of minus. If it is millimeter, then you have to do additional minus 10, minus 9, right? So that's the size, 1.15 angstrom. The moment you bend it, this becomes longer. It's just, shorter distance, very stable. And I am just activating. That's the magic I am doing here. We produce catalyst. I am not going to the detail, nothing to worry about the chemistry here. Okay, I take this compound this way, that way, different kind of this one, and this one. Anytime, any way you can bend it. This is the art of science we do. If somebody is really keen, want to learn much more, you can read the article. Forget about it. So, okay, so how much time I have? So, this is my group. I mean, what we do CO2 capture, CO2 reduction. You get the chemicals here, and we have a fuel cell lab, as in the introduction mentioned. We use that methanol in the fuel cell and use it. We have a hydrogen lab. We produce hydrogen. This hydrogen we integrate with this one. All hydrogen can be used in the fuel cell. If only hydrogen we use, you will get only water. If you are using methanol, you will get water and carbon dioxide. That carbon dioxide we capture it again and then convert it, and the cycle will go. What we do, we just make a lot of catalysts in that case. And this different process by thermochemical pole method, I'm not going to the detail. Applying temperature and pressure, lot of engineering involved in that one. Or another chemical method, maybe you will learn it later. And then photochemical method, this is actually exactly mimicking whatever the photosynthesis. We are making the catalyst, putting the sunlight, adding water into that one, and CO2 converting to whatever the chemical you are talking about, ethylene, ethanol, propanol, butanol, pentanol, etc. And biochemical, I am not working in that area. You make a lot of catalysts. Again, I am not going to detail. You can control the size of the catalyst, shape of the catalyst, and the support of the catalyst. You can generate the defects, singles atoms, heterostructure, gear lines. So many tricks in chemistry. Again, I am just passing that one. And I told you that one. This is a shell here. This coming from here, or bagasse or husk of shell. We process this one. You can see that we have this much amount of this metric ton of 6,760 metric ton of peanut shell is available. So what we propose that we can process and make it now. This compound, we make this compound from peanut shell, and we modify this compound by introducing nitrogen here. So you might have heard about Lewis acidity, right? Lewis basicity. When you introduce chemical, this guy absorbs CO2 and tune the acidity in a controlled manner. and more amount of CO2 will be absorbed into it. Okay. Again, we synthesize all this compound, even beyond that one. You can see that ethylene we discussed. Formaldehyde we did not come across. Ethanol, carbon monoxide, propanol, methanol, dimethyl ether, isobutylene, propane, hydrocarbon, ethane, acetone, formic acid, acetic acid. More examples. Continue. I will take one example, methanol. Methanol is safer because low risk of flammability. As I mentioned, fuel cell can be used. It can blend with the gasoline. If you Google it, M15, 15% of methanol blended with the gasoline, you can use it. M100, that's 100% of methanol, already when 20,000 taxis introduced by Chinese in Beijing. Or A20, 15% of methanol, 5% of ethanol, and A20, Italy. And US is actually Eton, those who are know that one, Eton, that's ethanol, 10% blended. Brazil is also 10% blended. What is the advantage with that one? It will be eco-friendly, less gas emission, whatever the CO2 emitted will be lesser than compared to the pure petrol or diesel. And if you look at the energy, you talk about hydrogen. Hydrogen is 1 atmospheric pressure. You can see that energy contained per volume. You can see that diesel, gasoline, propane, methane, all these energy fuels. If you if you want to have 200 atmospheric pressure, what you have to do? You have to apply the pressure. If you want to go to 350, 700 liquid, if you want to make hydrogen liquid, what to do? You have to have a high, heavy, pressure. This pressure comes with the cost of CO2 emission. Because pressure when you apply, you are applying electricity, energy. That energy is coming from somewhere. So, whatever we people talk about hydrogen, is it a renewable energy? Not really. It is also emitting a lot of CO2. Okay, the ground reality is, we cannot use 1 atmospheric hydrogen. Okay, and second one, the safety. If anybody wants to have the hydrogen cylinder in your car and then run, difficult, right? Okay, so then there are a lot of additional advantages you have here. I'm not going to the detail. And this is one of the biggest magazine you can ever think about, Science magazine. They introduced this methanol economy in 1973 when the oil crisis was there. And you can see that 1991 another science paper in Chicago, this gentleman is filling methanol in his car during the winter time. Okay? But because of ethanol was much cheaper, it can be produced from sugar cane or corn or whatever, and this did not happen there. And then this gentleman, he got Nobel Prize in 1991 for his contribution in carbonate chemistry. Oops. Right. And Surya Prakash is a Bangalorean living in Athinagar. He joined for a PhD in 70s with George Olah. He never left his post until he died. He continued his post part in 2020, 2019 he passed away. He's a professor in University of South California. And they started the one plant in Iceland. Okay? I hope you know Iceland geographically where it's located. And their production cost, capacity is around 4,000 tons of methanol per year. Okay? Why is it started? Because they have geothermal electricity. My question is, 1 unit electricity, what is the cost in Bangalore? 1 unit electricity. 7 rupees. Yes. It is in the range of 7 rupees. But if you have geothermal electricity, you don't have to pay a single money. But we don't have it in India. Okay, it's an abundant energy stored under. It's actually hot water, hot spring, and you can get the energy freely. So that cost is not accounted that one automatically, and the price is very less. You can Google it, George Olah's CO2 methanol plant. So later, another plant in Germany, but this never commissioned, until plant commissioned in China. with the catalyst manufactured by which company? Johnson Matthey. Continue. Well, then we enter into the game. We publish many papers, many patents. I have 15 patents, not just 6 actually. So many patents, and we scale up the catalyst. And then this is one 1 gram of methanol per gram of catalyst in an hour. This is the number, and we use. This is the catalyst we use for the global competition. Keep in mind, 0.6. You don't expect every catalyst can be scaled up, and we are significant. Okay. And continue. We use our startup company, as mentioned that one. We started in 2016, 2024, and we were only 2 companies. One is Breathe, another is a Carbon Clean Solution. Both are Bangalorean companies, started in Bangalore. Carbon Clean Solutions later moved to London. They have multi-plants on a CO2 capture plant. And the landscape of Stellar, India's climate tech landscape, we are only 2 Indian companies in the carbon sequestration of carbon capture. What we did actually, we did technology. If you come to JNCSR, we have a second campus. We built the facility, starting with the CO2 capture, CO2 conversion, enter completely, fuel cell and recycling, hydrogen unit and distillation and integrated and everything. So we did the demonstration to various industries like Shell, BPCL, couple of US firms, and we got an ISO certificate. If you Google it, Breathe, ISO certificate, 350 solution, you can get the document and you can learn the technology. And then we did the life cycle analysis. That is nothing but whether it's a sustainable process. This is done by University of Calgary, and they endorse that this can be neutral, taken with the condition hydrogen is producing from renewable source. So this is the facility we have in the second campus. You can see that my student is collecting methanol with a capacity of 300 kilogram per day capacity CO2 plant. Welcome you to come over there. Yes, we did a calculation methanol cost. When you say scaled up, you have to calculate the cost and market value. This was at that time. Now the market value is 65. The cost is also increased. You can see that if you look at the Asian Pacific region, this is around a 36 billion US dollar business is happening. And we extended this further. We built a plant in Telangana, Singareni Thermal Power Plant, funded by Coal India Limited and CMPDI. And this is a 650 megawatt power plant. We capture CO2 from the flow stream. So that with the chemical method, capture, we produce hydrogen. Hydrogen and CO2 mix together, and then we produce methanol. I'll finish quickly, almost done. Well, just then rest, okay? We use the stop. Okay. This is the catalyst we made in the lab. My student is actually working on that in different way of it. This is the reactor. This is a 300 kilogram capacity CO2 per day. It's in JNC campus. Okay. We are just measuring, understand the exact conversion activity. Very steady actually. You need a frame. So this all can be controlled in one single location. You don't have to build the reactor. All safety parameters are involved in that one. And we try to the okay. Thank you. Okay, so we have done this one way back in 2021, and this is the first CO2 methanol plant in India, for your information. Okay, and this was well celebrated in different newspaper and everything. What we have done? Okay, that is a 300 kilogram. Suppose I am going to make a 5,000 ton of methanol and CO2 in a day capacity, 5,000 ton. Because that power plant I will produce 22,000 ton of CO2 per day. Imagine this massive. Okay, what would be the cost of methanol? We just project out, we never did this, approximately 30. Now, where is the use? This 5,000 ton if you produce, then the marine industry, if you go to seashore, the new seaport inaugurated by Prime Minister in Kerala, Vizhinjam, the idea? All the big gigantic ships are being stopped there, they fill fuel, and it's a kind of business model. If you look at Singapore, what is the income of that country? They are filling petrol now. Yes, absolutely. Diesel basically, not even petrol. They are filling with diesel. Okay, so the revenue is coming with this ship, what you call business. Okay, all the ships are going to be stopped in Singapore. They are thinking about instead of diesel, if the engine is completely converted to methanol, the emissions can be reduced by 1/3 or 1/4 compared to diesel. Okay, but we don't have methanol cheaper than diesel at this moment. If anything, 1 rupee is lesser than that one, they are ready to buy from even trillion metric ton capacity. All this, the machinery, marine related, vehicles will be converted into methanol based engine. So business is there, but so we are working with the Tata Steel for CO2 to gasoline. We are working with the CO2 to ethanol. We are working with BPCL, CO2 to demiethyl. Again, HP with the CO2 to ethylene. Sadhguru CO2 to methanol. And we are also in discussion with the DRDO CO2 to food. Okay, CO2 to acetic acid process to protein. And they are looking for space exploration in future. In future, if you are going to stay in space, what will you do? Food. Okay, so you have to have the food production. They want to have some space exploration, whether the CO2, if it is abundant, can be produced food in space. Okay. And, well, these are some reactions you can make a CO2 in a carbon nanotube. You may use it. Okay. Carbon nanotube, you can make it. Pencil sheet kind, roll kind, you can make it. Next. Diamond. It's quite fancy, right? My student came with one day, when I came with some result, sir, I got diamond. I did not believe. Because when you need a high temperature, high pressure, basically. But when mixed with the CO2 and methane, at lower the temperature and happen, next month the paper published in Nature, similar data. We are yet to publish the data, but yes, it is possible. But don't think that is all can be commercialized. These are fancy science, actually, I would say, at this moment. Nothing over, tomorrow I will produce diamond from CO2. Don't think about that. Next one. DME. This is a company called Cogas. They have something around 300 kiloton per year capacity. They increase now. We also produce some dimethyl ether. And if you go to the next slide, government is in case looking for our LPG cylinder. LPG cylinder we can blend with the dimethyl ether. Now, if you remember, the cost of one cylinder is 850 rupees, something like that, right? So this cost can be 100 rupees can be reduced. And we use maybe 3 months, the efficiency will increase, maybe 4 months we can. So a small, middle class family, instead of a 4-cylinder using, they can reduce to 2-cylinder or 3-cylinder and reduce the cost of, that one something around 1,600 or 2,000 rupees. Not bad. So this is also going to, at the same time, CO2 emission is much lesser, in this case, compared to normal. Well, we can continue the story C1, C2. C1 means methanol, ethanol, propanol, butanol, ethanol, and gasolines. These in the discussed now. Different catalyst strategy. If you continue, then we just move ahead to the C12 to C18. That is sustainable aviation fuel. This is the holy grail of the technology. All the airline industries are looking for sustainable aviation fuel instead of jet fuel. Because the amount of CO2 emitting and the most growing aerospace industry is none other than India. And if you can, have in the technology as early as possible, it can reduce the CO2 emission. Please. Okay, This is my friend, he's in Cambridge. He made an artificial leaf and floated on water. Under the sun, to produce carbon monoxide from CO2. You can do it in principle. This paper, this, if you read, and you can get this information. So just made a different process in front of Cambridge University. I was there, and then it produced. Similar model we also made it for the methanol process under the sunlight. And this is a center of excellence. This is the first in the country. I'm heading the center of excellence, and we are looking for expanding this one to the different. We are going to start one in Innovation Technology Center also very soon in collaboration with British Geological Survey. That's the reason I went and then visited over there. And as a part of that one, we are happy to train the students. A kind of outreach. We typically go to, for example, schools like Navodaya and all to give the awareness, how this field is more important. If somebody is really keen, please talk to me. Okay, and finally, I would like to acknowledge all the people involved, all the funding agency. I was so lucky to have, both public and private funds, heavily supported, a lot of collaborations. And this all started with one man, with one full confidence, because I was appointed as one for teaching in academic institution. Going this far is quite difficult. This is none other than Professor Leena Rao. Okay, so from the day one when I did not have anything, he is the man, gave me everything. Well, I did not disappoint you. so he is very happy to give all this facility. Yes. And give a credit to my students. These are all my PhD students, postdoc students. Very bright, number one in the country. You always get number one in the country. Nowadays, we are both IIC level, CSIR, GATE, and first rank onwards, they come to us. And they produce all this catalyst technology, everything over a period of 10 years. And we are going through that one. Last two slides. I come with the two chords. Why this thing? All our dreams can come true if we have the courage to pursue them. Okay? You possibly. I am not coming away and so everything in my hand, nothing. Okay? If you are passionate about doing something, you can do it. But you will have the struggles. You will have the struggle. You try to find the solution for your struggles. You have to find the people to find the solution for your struggles. You can do it. Never ever go back. Pursue that. Second one. If you want to change the world, start with you. If you are not doing, who else will do? Right now? And don't look at, we will do, or no, you do it, don't look at others. If you want to really change the world. With that one, thank you very much. If you have any question, I'm happy to. Okay, fine.
Please.
Anyway, please. Hello. Yeah, please do ask questions before, after the question and answer session, of course, Sharanya will propose the formal vote of thanks. And, now, especially for the youngsters who followed it with lots and lots of interest, I'm really overwhelmed. I was thanking Mr. Jayachandra for facilitating the visit of and the gracing of this occasion by Professor Sebastian Peter. So you see now how difficult it is to understand. Lab experiments is one thing, how to scale it up and use it for industry economically. All of you are enlightened, I am sure about it. Please do ask questions and give him a big hand before that. Thank you, sir.
Questions?
Any questions?
Yeah, please.
I will tell you one secret to success. You should have the courage to talk.
Good evening, sir. It was a very wonderful talk. I have two questions. One is regarding carbon sequestration, where you mentioned we are storing carbon dioxide. I have this doubt that won't that affect the microbiome of that soil, a lot of carbon dioxide. And second is regarding artificial leaf, where you mentioned that we are reducing carbon dioxide to carbon monoxide. Why do we want to reduce it to carbon monoxide since it's a poisonous gas?
Oh, yeah, beautiful question. The first one, so we do a deep study when you do the sequestration. The sequestration is not at the surface, it's kilometers down. We pressurize kilometers down and then try to understand any chemical reactions can be involved in that. Yes, if you don't find a proper location, yes, it can do a chemical reaction. Not only microorganisms, it can also react with whatever all the minerals present there. And that can change the overall structure. So that study initially will do, identify, and based on the safety, even the leakage also can happen. If you are doing in a sequestration with million tons of CO2, if it is coming on what you call leaking, it is also not good for life. So that study is dedicated. The second question, yes, carbon monoxide is poisonous. I will recommend to read one article, SES Central and Science, good and bad side of CO, carbon monoxide. You are talking about the bad side, absolutely correct. But the good side, in industry, any chemical that is producing from CO, not from CO2 or humidity. So the CO2 to CO is thermodynamically a difficult task. And if all the CO2 convert to CO, the industry will be very happy to take all the CO2, produce any chemical effective. But you have to take care about all the safety norms. Okay, for example, if you come to my lab, even the ppm level of the CO is leaking. We have a sensor. Immediately we leak, and we'll take care of it. So that safety precautions, if you don't take it, yes, you're absolutely right. It's a process.
Any other question, please?
Thank you, sir. I like the meeting. I have this one question. Isn't carbon as important as it is toxic or dangerous?
It's important. It's important. Carbon in the form of, I told you, carbon nanotube. Carbon dioxide is also good side. Carbon dioxide, without carbon dioxide, how our plants will survive. That's a problem, right? So you need carbon dioxide to have an ecosystem. Otherwise, carbon dioxide will take from the plant, and then you get oxygen from plant, and then this is cycle. That is both are important. And 350 ppm I was talking about should not go below 350 ppm. You should not completely suck into CO2, then you are not. You should keep that level and then make the life in a very sustainable.
Thank you so much for the lecture. It was very interesting. Sir, I had a doubt. Like in this lecture, we learned how to recycle carbon. So, is there like any other way for us to recycle other greenhouse gases which doesn't have carbon in it?
So, for example, N2O, nitrous oxide, sulfur oxide. These are also problematic, poisonous in nature. Methane is a carbon one that is also, I would say, several 100 times dangerous than CO2. Methane is much more dangerous. But the amount of methane compared to CO2 is much lesser in every industry. That is the difference. But if the same amount of methane is asked to the CO2, you have that completely. It's called, what we call global warming potential, GWP. The GWP is something 200 times compared to CO2. Okay, it is very, very dangerous. Same with the nitrous oxide. Even the ppm level that can be very, very dangerous. So CO2 is not as dangerous as these three guys.
Any other question? Yeah.
Yes.
See whether we have done a study on the life expectancy based on this CO2. Like carbon say for this so less than some amount is bad, but how much it's bad if I go above?
We should not go beyond 450.
So currently it is 446.
426 also. This is a global average value. This is a global average. This is something done by an observatory in Antarctica. So they collect all the data and a very, 30 or 40 they calculate and then create it. Okay. So for example, in Bangalore, probably there is a 400, but if you go to Delhi, it may be 700. They collect all the data and average them to put it for the system. That's perfectly can do. If you go to a village or a remote area like a Chikmagalur and all, that's much less. But in a single place, it is not advisable to have, I would say even 500 maybe we can go, but at 500 end up with 2 degrees rise in temperature. So this is advisable not to go beyond 7. Same problem if you go to cement industry, the pollution in that one, not only what you call the powder, dust or something, but also the weather is different. Or if you come to my campus, you came to our campus in Sesa. Yeah. It is at least 2 degrees lower than outside. Just to go inside. The reason is actually we cover completely. That's the difference. The moment you just come outside, anybody come to our campus and going outside, they feel that you can call our campus as a research campus. The nature is, we don't even cut the branch also. We don't even cut it.
In the city, say I have 2 hours stay. So
I never travel more than half a kilometer. My house is half a kilometer from my office. I don't want to go.
We are exposed to more.
Absolutely. Absolutely. I can tell you, sorry, most of the kids born here, including my kids, okay, they will have the health issues in future. I'm telling you. And I know many of my friends, they already moved out of Bangalore because of the pollution. That can very damage. Explain this. But people want to come to conclude.
Any other question? What is the one thing that you support government trying to citizens of Bangalore and to ensure that it is better for the entire state as a scientist and as a researcher?
I am very unhappy with most of the governments, unfortunately. So our major problems in Bangalore, okay, is going to the public school. Number one problem, our traffic is the worst in the world. You know that one. As per the current report, it's the number one worst in the world. Right? There was a post in Facebook. You want to travel, Russia one side is Siberia, the other side of Russia. You need something around while driving 11 days or something like that. And then finally we want Bangalore post that. You don't have to go to Russia, come to Bangalore. It is. Number two, the waste management in the city, such a pathetic. Every river is full of waste. Is it not possible? I don't think so. Is it because of the government or we are not civic? Bangaloreans, 50% coming from outside, educated people, right? So we need you and everybody. How to do that one? And for that, infrastructure should be created.
So they say that electronic vehicles is much better compared to petrol. How do you think the contribution of EV is much better? Or is it the same?
EV is the problem. You want to recharge, right?
Yes.
Where you will recharge it? Where is that electricity coming from?
That's why I'm concerned.
And they say that this electricity is coming from. Actually, one difference is actually. When you just use the engine with the petrol and diesel, it is emitting CO2 on spot. Other one, the electricity already released by somewhere that you are using.
So that means that EV doesn't give a major contribution for global warming. It's just
I
the
don't
same
think
that's
so.
happening.
I don't think so.
And obviously that Bangalore EV vehicles will just reduce the pollution, but
Inside the city, emission will be less, but at the cost of emitting somewhere else.
Thank you, sir. And thanks for the lecture.
Sir, Sebastian, sir, it was so nice that you have packed so much of information in 1.5 hours, and it's so difficult for me to grasp everything. So that is one thing. Normally, from the studies, whatever we have seen, like any film, we have this hero and villain. So we can definitely associate this hydrogen and oxygen as the heroes, and carbon as the villain. Carbon is just like that, because carbon means it's really dark, and H2O means on the white side. So that is just one humorous thing which
I like KGF, anti-hero, I like that, and there's good heroes.
So what I was trying to, I just want some explanation. This ozone belt that we are telling about this carbon monoxide, and carbon is always the culprit, carbon dioxide, and it is so much harmful to human beings that it will always almost wipe away the human existence. That is one thing. But when we have this Amazon forest and they say that it is contributing to the oxygen, and depletion of Amazon forest will definitely increase more of carbon. And I think there is not much of information about the oceans. Even oceans do contribute to the oxygen levels in the atmosphere, isn't it, sir? And how best this carbon is absorbed in the ocean, that is one thing which I wanted to know.
Oh yeah, so that's the ocean sequestration, when we do that on artificial way. So ocean, one of the things you have to clearly think about, marine life, you have to balance it. And then pH should not change it. Okay. And the sequestration process, people do in ocean, that is the major technology. Almost 90% of carbon handled by ocean. Almost 90%. And we have a lot of belt under the ocean we can store.
I have heard about these planktons and the photosynthetic activity by the planktons. They just absorb so much of carbon and then they give out oxygen.
Oh, certain trees, I don't know the name immediately, certain trees, and you will produce more oxygen. You can Google it. The big branched tree. I'm not sure, that why people say that this kind of plants or this kind of trees should be planted. And that place, you will have more oxygen. And it's also good. It's exactly, there are so many things we don't want to do. I'm also learning.
Thank you.
Last 10 years, I'm still here. Every day I'm learning one or other thing. While reading, no, you will understand that one. I'm meeting the people. I have a little bit crazy things. All of a sudden, I take a flight and then I go to different part of the country and spend in the remote area. One such incident happened. With no reason, I went to Pune, I went traveled 2 hours, towards the sugar industry. That's the the hit I got, okay, I will build a plant in sugar industry. I'm building a plant over there. Without informing. But while doing that, visit, I learned a lot that I never knew before. To be honest, we don't know many things. That's actual fact. I'm talking about this field itself. I've learned a lot.
Okay. Sir,
Yeah, please, last question.
So increase in methanol production or the increase in mixture and So can it help in a reduction of global warming?
Not really. I'll tell you. So out of whatever the demand of this country, 90% of methanol we are importing from either from Iran or China. Okay. So that the limited use actually, but that will not. It's a matter of 1%, 2% of the quantity. But it is a massive area. So methanol is one component of that. It's not going to solve the problem. You have to think of every aspect, whatever But it's a correction. So, like me, 1,000 people working exactly in the similar area, yes, we can contribute in a better manner. 10,000 people, much more. Like COVID when it happened, we want a vaccination. The whole world will be chasing that one, right? And when the whole world was chasing it, actually, then we got the vaccine immediately. Because that was the necessity. Now we feel that it is not that urgent. It will take some time.
I have how effective the capturing of carbon dioxide, right, locally, right? Considering the global warming and all those things, if it is a very localized effort to capture the carbon dioxide, will it contribute much towards the?
Absolutely, absolutely. I will give you 4 different or 5 different industry sources. Okay. You take it in cement industry, that is close to 20%. Steel industry, 22%. Coal industry, 12%. Natural gas, 7%. And if you go for an chemical industry, 1 to 2%. Okay. Each one source, we are also doing that one. For one source, we can capture CO2. But the cost of capturing is also matter. Okay. So the cost in steel industry, cement industry maybe 30 rupees and $30 per ton. And if you go to the coal industry, natural gas industry, $60 per ton. So who will invest the money? That's the question. Okay. Then if you want to capture from 1% that will be $500 per ton. I don't want to invest money because I am not getting any money out of that profit. So when the money comes into the picture, that's the problem. So you can do beautiful science, but when reality comes, money will.
Whatever is technologically possible, may not taken up.
All these industry guys, no, they will keep silent.
Please. Thank you.
Thank you so much, sir. Thank you for such a compelling lecture. Not only raised awareness about the climate change from carbon, but also all the innovations that are happening in this field. I'm sure many students here will, be inspired by that and take up this maybe in future research. I once again thank Professor Sebastian Peter. Thank you so much. I thank people from JNCSR who coordinated with us in making this event happen. I thank all the lovely audience, those who are here and also those who have joined us online. And I thank all the JNP staff who have helped us in this event. Thank you one and all, thanks again. And see you in tomorrow's lecture on the same theme, carbon.
Tomorrow, the last lecture in this year's Dasara lecture series, that means 2025 Dasara lecture series. Again, one more professor from JNCASR is coming, Professor Sarita Agasti is coming, and he will be speaking on designing with carbon, the creative power of organic chemistry. Kindly do attend, especially kids, I would say, and young students, please do come and attend. It will also be an interesting lecture. But let me say that this was the most enlightening lecture for youngsters in this year's lecture series. Once again, I thank Professor Sebastian. Communicating science is an art and science is something, and he has excelled in that. Thank you so much again. And kindly do join for IT outside, and kindly do come for tomorrow's lecture. Thank you.
Subhana.